the quadratic formula. So it says in here, it says our final topic. This isn't our final topic in this unit. We're going to spend some more time. I'm going to add a couple things in before we wrap up the unit. So a third method for solving quadratics is the quadratic formula. So up until this point, we've factored, we've used inverse operations, meaning we have taken the square root, we have completed the square, and now we're going to bring in the quadratic formula. We've also dabbled with graphing. We haven't spent a lot of time with it, but you do know that when you graph your quadratic, your roots or your zeros are where the parabola crosses the x-axis. So let's talk about the quadratic formula. Now it does say in here, it says its proof or derivation, meaning where it came from, is beyond the scope of this course. Well, that's baloney. In class tomorrow, we are going to derive the quadratic formula. So for right now, we're going to look at it and use it in the video, but we're going to derive it in class, which is, in my mind, mind-blowing. It's super cool, though. So let's take a look at this equation here. It says solve it first by completing the square. Because first of all, I would look at this and I would try to say sum and product. So I'd try to think to myself, can I come up with two numbers that would add to 8 and multiply to 3? And after thinking about that, I'd say no. So therefore, it can't be factored. So if we go ahead and we complete the square, we say x squared plus 8x. We shove that constant over, and this is where we start, and we take half of 8, which we know, whoops, is 4, and then 4 squared to be 16. Now, I'm not doing this on the smartboard. I'm using my little handheld tablet thingy, and I'm in the closet between Mrs. Wall's room and my room. So, you know, anything could go on right now. One never knows. When I take a look at that trinomial, I can factor it into x plus 4. There's my perfect square trinomial squared, combining like terms, and I get minus 13 equals 0. So I have it in vertex form, so let's add 13 to both sides, and we get x plus 4 squared equals 13. That's a squared up there. Now let's undo. Now we can take the square root. X plus 4 equals plus and minus the square root of 13. The good thing about 13 is we can't simplify it. So now we're just going to subtract 4. And our answer is x equals, our answers, negative 4 plus and minus the square root of 13. And it says, what type of numbers does this answer represent? So hopefully by now, you know that when you take a rational number, negative 4, and add it or subtract it to an irrational number, you get an irrational number. So we can't possibly factor something with an irrational number as a solution. So this is where the quadratic formula comes into play. We have completing the square. Sometimes it's a little cumbersome. Quadratic formula, the cool thing about this, works all the time, every time. Doesn't matter what form your quadratic is in. You can always use, I shouldn't say what form, it has to be in standard form in order for you to use it. But if it can't be factored, you could use the quadratic formula. Maybe you should complete the square. Well, who cares? Maybe you want to use the quadratic formula. I'm saying is it works all the time for every type of quadratic. So that's what does make it kind of handy. Now, when you look at this formula, it does look a bit intimidating. And I can't remember if it's given to you or not. I'm going to say no, but I might be wrong. I'll let you guys know in class tomorrow. I can't remember if that's given to you. If not, we can sing this. Yes, I just said sing this to row, row, row your boat for you to memorize the quadratic formula. I know you want me to sing, but no, you really don't. So it says, okay, so let's go back to that same equation. And we know what the answers are because we completed the square. But it's going to walk us through the quad formula. So it says, what are the values of A, B, and C? Well, A is 1, B is 8, and C is 3. It says, let's see, the values of A, B, and C, and in the quadratic formula. Okay, so I think they just wanted us to list those out. All right, now it says carefully substitute these values into our formula and simplify and then compare our answers. Well, we already know the answers, so we better get it right. So when I go and I substitute into this formula, negative b, that means negative 8 plus and minus square root b squared, so 8 squared minus 4 times a times c. And I'm actually going to put, whoops, that 8 in parentheses. You'll see why later on when we get to a b that's negative. So let's just get into the habit of putting that b squared in parentheses. 2 times a. All right? So now it looks like there's a lot of calculation to be done here, but this piece right here that's underneath the radical, I'm going to tell you, go right to your calculator. X equals negative 8 plus and minus square root. So when you went to your calculator, you typed in 8 squared minus 4 times 1 times 3 and hit enter. So that meant you got 64 minus 12, which is 64, 54, 52. Square root of 52. Okay? That's allowed. Substitute what's underneath, go right to your calculator, and then continue the simplifying process. Okay? Now we've got to simplify that square root of 52 because it does have a perfect square in it, plus and minus. So 4 times 13, okay, hopefully we all agree that that's 52, 4 being the largest perfect square factor. So we get negative 8 plus and minus, the square root of 4 is 2, square roots of 13, all over 2. Now when we continue to simplify, I've talked about how certain things play nicely with each other and other things don't. Well, the numbers, okay, those rational numbers, the numbers that are outside the radicals, they play nicely with each other, so we've got to simplify. So what I highlighted in blue there, you need to think about what's the GCF. So the GCF is 2, so if we take out or simplify each piece of that by 2, so we get negative 4 plus and minus, really it's 1 square root of 13, but I'm just going to write square root of 13. And then 2 divided by itself is just 1. So my final answer is negative 4 plus and minus the square root of 13. And lo and behold, it does match what we did in the first example when we completed the square. Okay? So it says, students often prefer the quadratic formula to either factoring or completing the square to find the zeros because it is so algorithmic in nature. Algorithmic means it follows a process consistently over and over and over again. It's plugging into a formula. You guys are good at that. It's like a recipe that's right there. Okay? So I'm going to have you guys do exercise 3. It says first factor it and then do the quadratic formula. Okay, so you're going to factor it first, then do the quad formula. All right, go ahead, flip the page. So again, it gives you the quad formula right there, okay? A nice little graphic for us. It says the quadratic formula is particularly nice when solutions are irrational, okay? Just like completing the square is. Thus meaning you can't factor it. Factoring is going to be your go-to method if you can factor something, okay? It's going to get you to the answer the quickest. Sometimes we have to place answers to these questions in simplest radical form, and sometimes we need to come up with decimal approximations, meaning use your calculator, okay? I'm going to have you do A. We're going to do B together. So if I list out, and you will always do this, oops, you're always going to list out your A, your B, and your C. List them out, then go to your formula to substitute, okay? So x equals negative b plus or minus the square root b squared, I'm going to put my b in parentheses, minus 4 times a times c, all divided by 2 times a. Okay? So you list out your a, your b, and your c, you do your substitution, and then you grab a calculator, okay, for what is underneath the radical. Just what's underneath the radical. Don't put the radical in the calculator yet, okay? -4 plus or minus. So we end up with 16 plus 12, which is the square root of 28. So 28 should have popped up on your calculator when you entered that, all divided by 6. And I believe the direction said simplest radical form. So -4 plus or minus, how do we simplify 28? That would be 4 times the square root of 4 times the square root of 7, 4 being the largest perfect square factor of 28. So -4 plus or minus 2 square roots of 7, all divided by 6. Now I examine my answer and I look at the numbers that are outside the radicals, meaning all the rational numbers. Do they share something in common? Can I simplify it? And hopefully you're saying yes. The GCF is 2, so it becomes -2 plus or minus a 1 square root of 7, but I'm just going to put square root of 7, all divided by, when I divide 6 by that GCF, I'm left with 3. So that, my friend, looks kind of crazy, but that's definitely an irrational answer in simplest radical form. Okay? All right, now it says many times in applied problems, it makes much greater sense to express the answers, even if irrational, as approximated decimals, meaning you're going to get your final answers all through the calculator. Okay, so I'm going to have you guys do exercise 5 on your own. It talks about a projectile, okay, something thrown into the air. Go ahead, follow it through, and tomorrow we'll go over these in class, and we'll derive the quadratic formula. Good times, let me tell you. Bye, guys.